Yeah, sorry, I think I put myself on mute. Okay, let's see. Okay, we were talking about dehydration store last time. I think the long gap has its effect, guys. We're going to have a short session, just not to drop just like that. We will finish the deployment related stuff and then we'll close it for today. I think the last night's mail, people did not receive it yet, or Saturday effect. Okay. Either way, we're going to have a short session today. And the dehydration, the process itself. Now, last week, if you just recollect what we talked about, we deployed a composite. The composite has a WSDL, which is the way you access a service. A WSDL basically tells us the endpoint. Endpoint is how we access the service. WSDL basically tells how to access that service. Now, when you access the service, normally for testing purposes, we'll be using a browser or we'll be using a SOAP UI to do the testing. Now, when you invoke that service offered by the composite, it creates an instance. It's like a running state of a composite is called an instance. So if there are 100 users who are invoking that service, you will see 100 instances. Now each of these instances is at a different state at any point of time. Now what Oracle Server does is, instead of storing the state on the JVM, because the JVM can go down, it permanently stores the state of the instance to the database. Now in the database, this process of storing is called dehydration process. Especially the dehydration happens at a lot of points in a BPEL process, especially if it is an asynchronous BPEL process. You will have a callback, means service 1 called service 2. Now service 2 is going to respond back, but not immediately, because that's a synchronous call. So when service 2 calls back, alright, the service 1 should still be available, which means you need to store the state of service 1 somewhere permanently. So at regular intervals, the state of service 1 gets stored to a set of tables in the database. Now those set of tables is called dehydration store. The set of tables are called dehydration store. Now those tables all belong to one specific schema, SAV infra, with a prefix, and into these tables is where the state gets stored. The list of tables is this. It gets stored to cube instance, cube scope, work item, audit trail, audit details, delivery messages, bin, invoke messages, bin, deliver subscription. Now, you don't have to remember the table names or the contents of the table for that matter, but these are the set of tables that will store the state of the instance. This is an important state. Now, as SAV infra is running, so just like a WebLogic infrastructure, SAV infra also keeps running, so people will be accessing the services offered by the composites on SAV infra, or when events occur, things will get kicked in a composite. So what we do here is, every time an instance kicks in, the instance state, yeah, sure, we're going to have only a small session. Yeah, when the instance kicks in, we're going to store it into the database every time. Now obviously the database growth increases. If the load on the source servers is too high, the DB growth will be too fast. Means you will have the database growing at a very fast rate. Now that's one problem definitely. The second problem that you actually will have is when the instance state gets stored to the database, that's fine. But when you want to retrieve it, means you want to read it back from the database, and if the database size is too large or the database tables is too large, it will take longer to read from the database. So which means the performance of all the instances will be impacted directly the moment you have a very big database. So it's really important that you clean up or you keep your database size to minimal possible. So the instance states that you are storing in the database, you do not store anything that is unnecessary. For example, unnecessary state information would be like all the instances that have completed, let's say. The instances are completed. You don't need those states of instance, the payload that is stored in the databases, any information related to the instance that is completed is not required because it's done. So you need to remove all those details which are related to what is called completed instances. The same way faulted instances, let's say, especially the non-recoverable faults. We know that there are two types of faults. One is recoverable faults, the other one is non-recoverable fault. When the non-recoverable fault occurs, we know it's not recoverable. So when it is not recoverable, you don't want to store the state in the database. You want to remove it. Right? You want to remove anything that is non-recoverable. The same way, let's say stale instances. When do you get a stale instance? You'll get a stale instance when you shut down the composite and if the instances are still running. So all such instances for which the composite is shut down, they're called stale instances. Now obviously, the stale instances will not be able to continue. So you want to remove the state of the stale instances. The same way, anything that you have terminated, let's say a user has terminated certain instances, you want to remove those states. So there are, in each state of the instance, there are certain values that are certain instance states that you don't want to keep in the database. You want to remove those things. Now that process of removing is called purge. So the process of storing is called dehydration and the process of removing those states is called purging. These are two different things. You store it into the database from instance, it's called dehydration. You remove from the database, it's called purge. So you have to do the purging at frequent intervals. So obviously, why we are doing purging? We are doing purging to control the size of the growth, or we want to control the size of the, we want to control the growth. We don't want the database to be too large. So what we do is we want to remove the states that are not necessary. So we will be removing all the completed instance states, we'll be removing all failed instance states or faulted instance states, we'll be removing all stale states, anything that's terminated, like that. Now how frequently we do it? Obviously, how frequently we do it changes from company to company, project to project. If you have an environment where there are not too many instances getting created, obviously your database growth is not that fast. In that case, you will probably do it once a week. Otherwise, if you have a very loaded environment where there are too many instances getting created, like eBay, there are thousands of instances created every day. When you have such thing, your database also grows at the same rate. So what you usually do is you try to run a purging process, or you want to clean up your database every night, kind of. So you will run it, clean up process, let's say 1 hour in the night, couple of hours in the night, then you stop it. Then you run it in the second day, you run it on the third day, like that. So you will, every day you will have a couple of hours, and during the weekend you have a longer process to remove anything that is unfinished. And also finally at a monthly basis, again you might have a monthly purge. So what you usually do is, depending on the growth that you have, you might have depending on the growth of the database, you might have a daily purging, you might have a weekly, monthly, but it's not necessary that, or you can have both. Means daily also you run it for a couple of hours, and monthly whatever is remaining, run it at the end of the month, kind of thing. Alright, and how you do it? Oracle gives you a group of SQL queries, what we call SQL scripts. Let me log into our cloud server. So here if you see, I think let's go into students, online is where my RCO home. In the RCO home, RCO integration directory, you'll find Sova Infra, SQL purge. And here you see this is one of the scripts used for purge. We'll get deep into the purging and the related scripts later. That's an advanced concept. And this is one of the scripts provided by Oracle. This will go into the predefined set of tables and do the purging for you. Now because these are SQL related stuff and a database related stuff, most of the times the purging will be done by the DBA itself. Apart from the purging that was done directly at the database, we can also do the purging, middleware administrators, from the enterprise manager, the GUI that we have. But that will be for a couple of instances, like 1 or 2 instances. If you want to do large number of instances, the enterprise manager will throw out errors, timeout errors, because the enterprise manager has to go to the database, read it, then purge it. So it's instead of doing it from EM, we'll be doing it will be much more efficient if you do it from the database directly. Now who does the purging? The DBAs are the main ones that do the purging. Sometimes even we can give script to the what we call the client. The client can run the script in JDeveloper, which will connect directly to the database and purge it. Especially if the client is not sure yet, let's say they don't have a purging strategy now. they don't know if they can remove all the instances that are completed today or not. So they will run it at random intervals, like when they think that okay, this today we don't need it, or we can we'll stop it for a couple of days. It's their dish. Alright, so that's purge. Now just to recollect everything once, I'll just go by the entire deployment thing. So we are talking about SCA, which is a standard. I'll just recollect everything that we are doing here. See this one, all these things. SCA is a service connector architecture. Based on this architecture, the composites are created. Composites internally can have some of the components, all of the components, depending on the logic. And what are the components we have? We have a BPL component, we have a mediator component, human workflow component, decision services, business rules component. Then we have Spring context component. Now these components will together bundled into a jar file. We call it a composite. A composites can have multiple versions, so they are called revisions, 1.0, 2.0, 3.0, like that. Now these, when you deploy these revisions or when you deploy these components, a group of composites is called a partition. So once you deploy the composites, you invoke the composites. So there is a service offered by the composite. When you invoke that service, it creates an instance. So instances keep running, they complete or they fail. When they fail, it's called a fault. Now when the instance is running, it might call other services. When it calls the other services with the wrong input, so the other service is going to reject its input. That rejection is called a rejected message. Then the instance states get stored at regular intervals to the database. This process of storing is called dehydration, and the location where they are stored is called the dehydration store. So here we are talking about, this is enterprise application, and against enterprise application you have SCA application. All SCA applications are basically, they call it service component or service connector architecture, whatever you call it. They are service oriented applications, SUBA applications. Alright, then there are composites with a lot of components inside them. This is a composite so this is a component structure. This is wrong here on the top. It's a component, and multiple such components will form a composite end to end, and that gets deployed to a SCA domain that we have here. These are revisions we are talking, and the naming convention of a composite. So it should start with SCA underscore the whatever name it is and the revision. These jar files, if they are combined together and you are given as a zip, it's called a SAR file here. This is the deployment steps you will see from the enterprise manager. In deployment, this is where you got it. These are the states of a composite. You can have it started, which is usually after you deploy it. If you can shut down a composite. The same way you can have active and retire. These are two modes of a composite. When you retire a composite, all the instances will still be running, they will continue. But when you shut down, they will become stale, means they won't continue any further. These are the versions that we talked about. Each of the versions has a specific URL. So when the customers are calling, when the client is calling, or the consumer is calling, they have to use that specific URL. Then partitions. Partitions are basically group or a logical group of composites. You can shut down all the composites within a partition at a time. You can start all the composites within a partition at a time, like that. It makes the managing things easy. That's it. There's no other use than this one. Partitions cannot be renamed, so you have to delete the partition and recreate it if you want to rename. Again, to a single partition you cannot deploy the same revision of the composite, but two different partitions can have the same revision. This is the deployment, and that's the partition that you are looking at on the screen, the default partition. Then once you have deployed the composite, we talked about instances. Instance gets created when a composite gets called, and the state of the instance gets stored to the SO infra schema. Schema is a group of tables, that's it. There is nothing like schema. The username and the schema name are usually same. So when you say username, you're talking about a user. That user has an associated schema name. Now SO infra is called a dehydration store. Each instance has an instance ID, and each business transaction has an execution context ID. So ECID may have a lot of instance IDs within it. Means one business transaction may call a lot of composites. When you call a lot of any composite, your instance ID gets created, but the ECID will still remain the same. Alright, these are the states of the instances, 4 states: running, faulted, completed, stale. These are the faults. You got business faults, you got system faults, you got OWSM faults. Any of these faults, some of these faults are recoverable, other faults are non-recoverable. Same way you got rejected messages. Rejected messages are when a composite calls outsider and the outsider did not respond, or a composite called outsider with wrong inputs. It's called a rejected message. So some of the faults are recoverable, non-recoverable faults. If they are recoverable, these are the various things you can do with it. You can retry it, you can abort it, you can say rethrow the same error, or restart everything again, or continue just by ignoring the fault. If there is a rejected message, you simply delete the rejected message. Then dehydration store is mainly for asynchronous BPL callbacks. This is the dehydration store location, SO infra schema. There are a group of tables in that. Our MDS is basically a group of, this is irrelevant here. These are the list of tables in the dehydration store. Then you keep the, you want the dehydration store not to grow too large, so you keep deleting instance states from the dehydration store. The process of deletion, or the process of managing the growth, is called purging. So there are Sql scripts to do the purging, and there is also enterprise manager. It can do the purge. Enterprise manager based purging is very, it's not recommended because it's not possible pretty much. Means you cannot purge a lot of data using enterprise manager. So the DBAs will be doing a purge. There are a set of SQLs already provided by Oracle Source Suite in the RCU utility. A DBAs will have to execute those scripts so that all the completed instances, non-recoverable faults, and anything that you don't want can be removed. Alright, that's all. So that's all we have for composites, deployments, instances, dehydration stuff. I'm going to stop it here for today because a lot of people are yet to come in. Also, you guys get kind of little refreshed. So make sure you go through all the videos once at least today. Everything gets refreshed. We're going to have a longer sessions from tomorrow onwards.